Hello students, how you are doing? So in the applications of derivatives, we studied derivative as a rate measure, increasing decreasing function and equation of tangents and normals. In the today's class I will start with the maxima and minima. There is a method in the textbook, but I will give you a very simple method. Before moving to any examples or questions, first see what is the maxima and minima. Here a continuous function. A continuous function, if it goes on, see, if a continuous function, it goes on increasing and it reaches certain height. After that it goes on decreasing. This point, where it reaches a certain height, that is called, where it reaches that point is called maxima. That point is called maxima. Suppose x is equal to, suppose that whatever the value 2, at the point 2. The point is called maxima, and if you write that value in the curve we are taking as a y is equal to f of x. If you write that value in the curve, that gives you the maximum value. And in some cases the curve, it goes on decreasing, it reaches a continuous function, goes on decreasing and it reaches one certain level. After that it goes on increasing. Where it reaches the minimum value, that is called minima. Minima at that point is called minima, and if you write down that value in the curve, that gives you minimum value. And I am giving you very simple concept, simple method here, how to find the maxima and minima. So don't go to that NCERT. Comparing to NCERT, I will give the simple concept. And now the students have the confusion whether if you solve by this method you will get the marks or what. Yes, in the examination they will not ask the mention, they will not mention the method, they will not mention use this method or that method, just they will ask the find the maxima and minima. So I will give you the one important concept. One curve is given for you first in the form of x. What is the first step we have to find? First step is find dy upon dx, first derivative, and then equating dy upon dx with 0. That means you have to write dy upon dx is equal to 0. And after solving dy upon dx is equal to 0, you will get certain points. You can get as 1 point, 2 point, 3 point, depending on the equation. You can get certain values. That points are called critical values. For example, A, B, C, or stationary points. So, and first we have to find the first derivative. Note down that steps carefully. First we have to differentiate. Then you have to equate that differentiation value with 0. You will get the points. Then go for the second derivative. Find, this is second point, third point. Find second derivative d square y upon dx square. First step, find dy upon dx, equate the value with 0. Then you will get a values. Then go for second derivative. After finding the second derivative, whatever the calculated values, substitute that values in the second derivative. Substitute the values in the second derivative. For example, at x is equal to a, if you get the second derivative as a negative answer, second order derivative, after writing the value in the second order derivative, if your answer is negative, then the function is maxima. The function is maximum at x is equal to a. And the maximum value means whatever the value, that value you have to write it in the given problem. That value you have to write it in the given equation. This is the first point. And second one, suppose if you take at x is equal to b and you are getting the second order derivative as a positive. Positive means greater than 0. Positive values greater than 0. So at that time the function is minimum. The function is minimum. Please note down this carefully. And the minimum value means you have to write that value in the given equation. We have to write that value in the given equation. Understood? Again, I will repeat this concept when we are solving the example. Now we are moving to the towards example from NCERT. Moving towards the exercise 6.5. See the first question. Find the maximum and minimum values if any of the following functions given by. So I will explain the concept slowly. Again I am repeating that. F of x is given. What is the first step? We have to find the first derivative. Yes. Differentiating with respect to x. F dash of x is power 2 into 2x minus 1 whole square into differentiation of 2x minus 1 and differentiation of 3 will be 0. It is 2 into 2x minus not whole square, it is 2x minus 1. It is in the form of n into x to the power n minus 1 into differentiation of 2x is 2. So it is 4 into 2x minus 1. First step is completed. Second step what? For maxima or minima. For maxima or minima, dy upon dx should be 0. We have to equate the first derivative with 0. That is 4 into 2x minus 1 is equal to 0. Taking 4 on that side, 2x minus 1 is equal to 0. Therefore, x is 1 by 2. Now we got a x value. Now differentiate this. We have to find the second derivative. Here if you want, you can write dy upon dx or f dash of x. Both are correct. Now differentiate equation 1 again with respect to x, because we have to find the second order derivative. Differentiating equation 1 with respect to x, that is double derivative f double dash of x, 4 constant. Differentiation of 2x minus 1 is what? 2. Here see the interesting thing, we are not substituted the value. Without substituted the value also we got a positive answer. So if you want, just write down at f double at x is equal to, even though we are not substituted, because already we got the value, it is greater than 0. Greater than 0 means it is a positive. For second order derivative is positive. Even though if you not write this also, it is correct, because without substitution we got the only value, positive value. The function is minimum. The function is minimum at x is equal to 1 by 2 and minimum value is in the given function, wherever x is there we have to write 2. 2 into 1 by 2 minus 1 whole square plus 3. This 2 and this 2 get cancels. 1 minus 1 is 0. 0 plus 3 is 3. And the minimum value is 3. Moving to the next example. Second one. F of x is equal to 9x square. Second problem. In the first main question, second one. F of x is equal to 9x square plus 12x plus 3. See, already we are familiar with the method. First step is what? We have to find the first derivative, differentiating with respect to x. F dash of x is 18x plus 12. First step is completed. After first derivative, we have to equate with 0. For maxima or minima, f dash of x is 0. That is 18x plus 12 is equal to 0. So here we completed the first derivative. After first derivative, we have to equate that first derivative with 0 to find the maxima and minima. See here, 18x is equal to minus 12, x is equal to minus 12 by 18. So after cancellation, x is equal to minus 2 by 3. So after finding the x value, what we have to do? We have to go for the second derivative. We have to equate the equation 1 again with respect to x. Differentiating equation 1 with respect to x. So f double dash of x is 18. See, again is it interesting or what? Yes, without substitution we got the answer positive, greater than 0. So the function is minimum. Positive means minimum. The function is minimum at x is equal to minus 2 by 3 and minimum value is y minimum. You can write like this. I will show all the methods how to represent. Instead of f of x, you know that you can write this as a y. And y minimum, minimum means 9 into minus 2 by 3 whole square plus 12 into minus 2 by 3 plus 3. This is 9 into 4 by 9 plus 3 ones are 3 fours are 12 plus into minus is minus 8 plus 3. This 9 and 9 get cancels. It is 4 minus 5. Minus 8 plus 3 is minus 5 and answer is minus 1. 4 minus 5 is minus 1. Yes. Moving to the third question. Moving to the third question, f of x is equal to minus x minus 1 whole square plus 10. Here as usual first we have to find the differentiation. Differentiating with respect to x. F dash of x is minus 2 into x minus 1 into differentiation of x minus 1 is not necessary because x is 1 and differentiation of 10 is 0. Next, for maxima or minima, f dash of x is 0, that is minus 2 x minus 1 is 0 implies x minus 1 is equal to 0, so x is equal to 1. In the previous sum, instead of plus 2 I wrote plus 3, make it plus 2 and please check the last answer in the previous example. Now after finding the x value, differentiate equation 1. Differentiating with equation 1 with respect to x. F double dash of x is minus 2. So it is less than 0. See the interesting thing, here also we are not did any substitution. Directly we got negative answer. The function is maximum. The function is maximum at x is equal to 1 and the maximum value is, and y maximum is minus 2 minus 1 whole square plus 10. It is minus 3 square is 9 plus 10. That answer is 1. Moving to the next question. So x value is 1. X value is 1. It is 1 minus 1. 1 minus 1 is 0. 0 plus 10 is equal to 10. I did a mistake. So x is equal to 1. We have to write x is equal to 1. Please make the correction of that. Now moving to the next question, that is the fourth one. G of x is equal to x cube x square plus 1. G of x is equal to x cube plus 1. First step, differentiating with respect to x. G dash of x is 3x square. For maxima or minima, g dash of x is equal to 0. That is 3x square is equal to 0 implies x is equal to 0. Now differentiate equation 1 with respect to x, because we have to find the second order derivative. Differentiating equation 1 with respect to x. It is g double dash of x is 6x. At x is equal to 0, g double dash of x is 6 into 0, that is 0. And one interesting thing, for 0 we cannot say it is a plus 0 or minus 0. We cannot judge a sign for 0. So this implies the function is neither maximum nor minimum. The function is neither maximum nor minimum. So this is how we are solving. Now I am moving to the second main example, second main question in the exercise 6.5. See, in the exercise 6.5, the second main question, find the maximum and minimum values if any of the following functions given by. See, again the sums are very interesting. Going for the sums, first one, f of x is equal to, here I am not giving that concept whatever I explained in the example main question 1. First one, f of x is equal to modulus of x plus 2 minus 1. See here, modulus is what? Modulus is always positive. Mod of any number is always positive. That means this modulus, we are familiar. I am not going for the previous concept. We know that modulus of x plus 2 is greater than or equal to 0. It may be 0, but not a negative value, because modulus of any number is always positive. And what we required? We required minus 1. X modulus of x plus 2 minus 1. Already we are familiar with inequality. So what we are doing? I am taking minus 1 on both the sides like this. It is modulus of x plus 2 minus 1 greater than or equal to minus 1. And this is for what? This is for every x belongs to set of real numbers. Therefore, when you observe this, this is a greater than or equal to 0 and it is minus 1. You are getting negative or what? Negative means what? Therefore, the minimum value of f is attained when modulus of x plus 2 is 0. If you write this as a 0, you will get minus 1. Minus 1 is a minimum value. Implies x is equal to minus 2. Therefore, minimum value of f is f of minus 2, that is modulus of minus 2 plus 2 minus 1, that is 0 minus 1 is minus 1. And there is no maximum function. Note down please these examples, we are not applying any differentiation. Hence, the function f does not have a maximum value. does not have a maximum value. Yes. Depending on that positive and negative, not applying, without applying a differentiation. Moving to the next example. G of x is equal to minus of mod x plus 1 plus 3. So minus of mod x plus 1, is it less than 0 or what? Yes. We know that minus of mod x plus 1 is less than or equal to 0 for every x belongs to R. Therefore, g of x, but we require plus 3 on that side. G of x is equal to minus of x plus 1. Add plus 3 on both the sides. That is less than or equal to 3. So, less than or equal to 3 means what? For every x belongs to R. Here plus 3. Plus 3 means is it maximum value or what? This we have to observe. The maximum value of G is attained when is equal to 0. That is x is equal to, when it becomes 0, then only we are getting plus 3. Plus 3 is the maximum value. Write on that value, you will get the maximum value. Hence the function, the maximum value of the function maximum value of G is G of minus 1 is minus of mod minus 1 plus 1 plus 3. 0 plus 3 is equal to 3. Hence, function G does not have a minimum value. Moving to the third question. What is the third question? See, the third question is h of x is equal to sin 2x plus 5. See, already you are familiar. Sin is a trigonometric term. Its maximum value is 1 and its minimum value is minus 1. Sin is lying between minus 1 to plus 1. But what we required? We required sin 2x plus 5. Add 5 for each term, each expression. This is exactly belongs, it is similar to the first year linear inequality. This is 4 sin 2x plus 5 less than or equal to 6. By observing this only we can say that sin 2x is lying between 4 and 6 means the minimum value is 4 and the maximum value is 6. Hence, the maximum and minimum values are 6 and 4 respectively. Yes. Moving to the fourth question. Moving to the fourth one. F of x is equal to modulus of sin 4x plus 3. Both are under modulus. So here again you know that the sign is lying between minus 1 to plus 1. Sign is lying between maximum value is +1, minimum value is -1. But we require sin 4x plus 3. Add 3 to each term, each expression. Now take a mod. Modulus of positive numbers is positive. Hence, the maximum and minimum values are 4 and 2. See, in these examples, without applying a differentiation, we are solving. Moving to the next question. Fifth one. H of x is equal to x plus 1, where x is lying between -1 to +1. So, that means we are not taking the end values. It is strictly lying between -1 to +1. That means what it includes? It implies that it is lying between, x is lying between -1 to +1, but we require x plus 1. That means add 1 to each expression. Add 1 for every expression. What we are observing? We are observing this. See, but it is given x should lying between -1 to +1. See this 0 and 2. They are not in -1 and +1. This implies this is h of x. Now h of x is not in between -1 and +1. H of x has neither maxima nor minima. Nor minimum value. Understood? Yes.